Hi everyone, today we're talking about radicals. Now we did a little bit of radicals when we did completing of the square in Unit 1, so again this may be also a little bit of review in the beginning. So let's talk about radical vocabulary. The little n represents the index, or it's telling you what root you're taking, square root, cube root, so that's your index, I-N-D-E-X. The number under the radical symbol is called your radicand. He is who you are taking the root of. All right, now the most popular one you're used to is square root. The square root of a number is one of the two equal factors whose product is that number. Let's talk about some perfect squares. Well, 1 is a perfect square because 1 times 1 is 1. 4 is a perfect square because 2 times 2 is 4. 9 is a perfect square because 3 times 3. And if we went out, it would be 16, 25, 36, 49. 8 times 8 is 64, 81, 100, 121, 144, and it goes on. Dot, dot, dot. Now let's talk about perfect squared variables. You've got to remember, when you're squaring a number, you're multiplying it by itself. But when you're actually squaring a variable, you are actually adding it. So a perfect squared one would be x squared because x times x to the first times x to the first, 1 plus 1 is 2. The next one would be x to the fourth because x squared times x squared, 2 plus 2 is 4. Then it would be x to the sixth because 3 plus 3 is 6. Are you getting the hang of this? Then it would be x to the eighth. Not to the ninth, because no number adding to itself would give me 9. Remember, when you multiply with exponents, you add, or variables with exponents, you add the exponents. So then it would be 10, x to the 10th. Well, let me make that a little bit nicer there. Then it would be x to the 12th. Are you noticing that all the even numbered exponents are perfect squared variables? Okay, let's move on and see what we can do with square roots. The square root of 49 is, and they drew the square root symbol for you, so it's just plain old 7. The negative square root of 121. Well, the square root of 121 is 11, and they want you to give me the negative answer, so it's a negative of 11. The square root of 100 x to the fourth. Well, the square root of 100 is 10, and x to the fourth would be x squared. Okay, and we're moving kind of quickly today because you also have the Let's take a look at cube root. Now in cube root, you can actually use your calculator. The cube root of a number is one of 3 equal factors whose product is that number. Let's talk about some perfect cube root guys. First one would be 8 because 2 times 2 times 2 is 8. Next would be 27 because 3 times 3 times 3 is 27. What do you think the next one would be? You're right, 64 because 4 times 4 times 4 is 64. And then 5 times 5 times 5 is 125. And you could keep going on just like you could for the square root list. Let's talk about cube variables though. Remember, you're looking for a number when added to itself 3 times will give you that number. So your first one would be x cubed because 1 plus 1 plus 1 is 3. Then it would be x to the 6th because 2 plus 2 plus 2 is 6. Then it would be x to the 9th because 3 plus 3 plus 3 is 9. Remember, you're adding the exponents. And then it would be x to the 12th, and so forth and so on. All right, cube root of 64. What number times itself 3 times would give me 64? You're correct. It is 4. Now we want to take the negative cube root of a negative 1. So we're going to take out our calculators and clear your screen. You're going to hit negative, and then you want cube root. So you're going to go to Math button, and you're going to push number 4 for cube root. You're going to plug in a negative 1 and close the parentheses if it opened up a set of parentheses for you, and you're going to hit enter. And your answer is a positive 1. Now if we were to do this by hand, we'd bring over the negative, The cube root of a negative 1 would be a negative 1 because a negative times a negative is a positive times a negative is a negative 1. And a negative of a negative is a positive 1. So you either can do it by hand or on the graphing calculator. All right, let's talk about nth root. What do they mean by nth root? Well, nth root is, you're finding the nth root of a number is one of the n equal factors whose product is that number. So now you're not looking at square root or cube root, you're looking at another root. It could be 5, 7, 9, whatever it is. And again, in this actual root, you can actually again use the calculator. So we're going to take our calculators out, and we're going to clear our screen, and we're going to hit actually the root first, which we're going to plug in 5 first, and then hit the math button. And this time we're going to select number 5 where it says the x root because we're telling them we wanted to use 5. Plug in 32 and hit enter and your answer is 2. Or if you could have done that one in your head, 2 times 2 times 2 times 2 is definitely 32. Try number 7 all by yourself in the calculator. Pause the video and then come back and see what you get. So hopefully you put 9. You went to the math button, you scroll down to number 5, plugged in negative 1, enter, and ended up with a negative 1. And if you didn't get that, you might want to pause the video again and try again until you get it. And if you're having problems with the calculator, bring those questions to class tomorrow and we will go over the calculator steps again. Let's move on. So now we're actually going to simplify radicals. And we did a little bit of this in Unit 1, again with completing of the square. The important properties. When you're multiplying, you can actually put each factor under its own radical symbol. When you're dividing, you can also give a radical symbol to the top and the bottom. And squaring and square root actually cancel each other out. So you're actually taking the absolute value of that answer because you'll never get a negative in that case. All right, recall our perfect squares and perfect cubes. Let's do number 8. 1/4 square root of 128. Well, 1/4 is on the outside, so really I'm not going to do anything with it right now, but bring it over. I need to simplify 128. First of all, is 128 a perfect square root? It's not. So how do I do this? Well, I'm going to use my perfect squares root list to help myself. Where would 128 fall if it was on the list? It would be somewhere out here. So I'm going to go backwards up the list until I hit a number that goes into 128 evenly. The first number I hit is the largest factor that will go into it evenly, so that's the one I want to use, so I don't have to do this more than once. So 100 won't. Will 81 divide into 128 evenly? No. What do I mean divide into it evenly? Well, if you go 128 divided by 81 in your calculator, do you get a decimal? If you get a decimal, that means it doesn't go into it evenly. All right, next would be 64. Does 64 go into 128 evenly? Yes, you're correct. 64 times 2. So now, bring down the 1/4. The square root of 64 is 8. When 8 comes out to meet the 1/4, they multiply. The square root of 2 I can't do, so he stays under the square root symbol. So 1/4 of 8 is 2, so my answer is going to be 2 radical 2. All right, let's take a look at number 9. 3 radical 200x squared. Okay, the 3's on the outside, so we're not going to touch them. Let's simplify radical 200x squared. Well, 200 would be 100 times 2. Do you agree? And isn't x squared a perfect square root? So I'll just leave them as is. So the square root of 100 is 10, and when 10 comes to meet the 3, they multiply, so I get 30. I can't take the square root of 2, and the square root of x squared is plain old x. So my answer is going to be 30x radical 2. Moving on. Number 10. The negative square root of y plus 7 to the 16th power. Well, we're actually square rooting the 16th power. And 16 is a perfect square root because it's an even number. So my answer is going to be the negative of y plus 7 to the, you're right, 8th power. And then I'm done because I eliminated my square root symbol. Let's take a look at number 11. And the cube root of n to the 7th. Well, n n to the 7th is not a perfect cube root because there's not a number plus itself 3 times that'll give me 7. So this is how you do exponents when they're not perfect cube root or square roots. You're going to actually go down one exponent. So instead of writing n to the 7th, you're going to write n to the 6th times n. Because really n is n to the 1st, and n to the 6th times n to the 1st is n to the 7th. Well, n to the 6th is a perfect cube root because 2 plus 2 plus 2 is 6. So the cube root of n to the 6th is going to be n squared. I can't take the cube root of n, so it's going to be n squared cube root of n. And there's my answer. Let's take a look at number 12. In number 12, it's negative 2x square root of 72x cubed y to the 4th. Okay, we're doing square root. So the negative 2x comes over. Here's my radical. So I need a biggest perfect square root that'll go into 72. So my mind is thinking, 4 is a perfect square root, 9, 16, 25, 6 times 6 is 36, 49, 64, 81. Well, 72 falls in here. So if I start going backwards up the list, what's the biggest perfect square root that'll go into 72? 64? No. 49? No. 36? Yep. 36 times 2. Is x cubed a perfect square root? No, it's not. So we're actually going to go down one and go x squared times x, because x squared is a perfect square root. Is y to the 4th a perfect square root? Yes, it is, because 4 is an even number. So now let's simplify our answer. Square root of 36 is 6. When 6 comes out to meet the negative 2, I get a negative 12. I can't take the square root of 2. Square root of x squared is x. When x comes out to meet the other x there, they're multiplying, I get x squared. Square root of x I can't take. Square root of y to the 4th will be y squared. He comes out, and just going to multiply him by everybody else. So let's see who's left inside the radical symbol. Just a 2 and an x. So my final answer is negative 12 x squared y squared square root of 2x, or negative 12 x squared y squared radical 2x. Okay, our last one, cube root of 48. Okay, now remember, you're thinking of the cube root list. So let's write the cube root list a little bit here. So if we're thinking of cube roots, it would be, perfect cubes would be 8, because 2 times 2 times 2 is 8. Then it would be 27, 64. Oh, that's as far as I need to go, because 48 would fall right in here. Now I ask myself, can 27 go into 48 evenly? No. Can 8? It sure can. So I'm going to rewrite it as a cube root of 8 times 6. The cube root of 8 is, you're exactly right, 2. He comes outside. He's got nobody to meet, so he just comes out by himself. I can't take the cube root of 6 evenly, so he stays inside. So my answer is 2 cube root of 6. And there's my answer. Tomorrow in class, we're going to learn how to simplify more by practicing some problems together. Have a good evening.